Hello everyone, I'm Said and welcome back. Today we're gonna solve three interesting integrals. Number one, the integral of dx over sine of x times cosine of x. As you know, sine squared of x plus cosine squared of x equals 1. So let's replace the 1 in the numerator with this expression. So we have the integral of sine squared x plus cosine squared x over sine of x times cosine of x dx. Now we can split this into two separate fractions, means the integral of sine squared of x over sine of x times cosine of x dx plus the integral of cosine squared x over sine of x times cosine of x dx. Now we simplify each term by cancelling out the common terms. In the first part, 1 sine of x cancels out and leaving us with sine of x over cosine of x equals tangent of x. And in the next part, 1 cosine of x cancels out and leaving us with cosine of x over sine of x, which is cotangent of x. So the integral becomes tangent of x dx plus the integral of cotangent of x dx. And as you know, the integral of tangent of x equals negative ln of the absolute value of cosine of x, and the integral of cotangent of x equals ln of the absolute value of sine of x plus c. If we're using the property of logarithms, means ln of a minus ln of b equals ln of a over b. So we have ln of the absolute value of sine of x minus ln of the absolute value of cosine of x equals ln of the absolute value of sine of x over cosine of x plus c. Since sine of x over cosine of x is tangent of x, so our final result is ln of the absolute value of tangent of x plus c. Number 2, evaluate the integral of dx over 1 plus sine of x dx. First, we use the conjugate of the denominator, so we multiply the numerator and the denominator by 1 minus sine of x. So we have the integral of 1 minus sine of x dx over 1 minus sine of x times 1 plus sine of x. Now we use the identity, means 1 minus sine of x times 1 plus sine of x equals 1 minus sine squared of x or cosine squared of x. So the integral becomes the integral of 1 minus sine of x dx over cosine squared of x. Now we split the fraction into two parts. So we have the integral of 1 over cosine squared of x dx, right? Minus the integral of sine of x over cosine squared of x, minus the integral of sine of x over cosine squared of x dx, right? The first integral is the integral of 1 over cosine squared of x cosine squared of x dx equals the integral of secant squared of x dx equals tangent of x plus c. And the second integral is the integral of sine of x over cosine squared of x dx. We use substitution, means let u equals cosine of x. So if we take the derivative of both sides, we have du equals negative sine of x dx, right? So the integral of sine of x over cosine squared of x dx equals the integral of sine of x dx equals negative du over cosine squared of x equals u squared. So we have negative the integral of u to the power of negative 2 du. If we use the power rule, we have negative 1 over negative 2 plus 1 u to the power of negative 2 plus 1 plus c, right? So we have negative 2 plus 1 equals negative 1. So negative 1 over negative 1 is positive 1. So u to the power of negative 2 plus 1 equals u to the power of negative 1, or 1 over u plus c. And we know that u equals cosine of x. We have 1 over cosine of x plus c, or 1 over cosine of x equals secant of x plus c. Now putting both parts together, so we have the integral of dx over 1 plus sine of x equals, first integral is tangent of x, right? So the integral of 1 over cosine squared of x equals tangent of x, and the integral of sine of x over cosine squared of x, of course with negative, is secant of x. So we have tangent of x minus secant of x plus c. Number 3, the integral of dx over cosine squared of x times the square root of 1 plus tangent of x dx. Let's use the substitution method. We'll set the expression inside the square root as u, so u equals 1 plus tangent of x, and now we need to find du. The derivative of 1 is 0, and the derivative of tangent of x is secant squared of x, which is the same as 1 over cosine squared of x. So we have du equals 1 plus tangent squared of x dx. The derivative of tangent of x is secant squared of x, or 1 plus tangent squared of x, or dx over cosine squared of x. Now look at our original integral. We have dx over cosine squared of x right there. This entire part simply becomes du, so we can rewrite the integral in terms of u. So we have this integral equals the integral of du over the square root of u, or using exponents, u to the power of negative 1/2 du, right? Now we apply the power rule for integration, means 1 over negative 1/2 plus 1 u to the power of 1/2, negative 1/2 plus 1, and we know that u is 1 plus tangent of x. So negative 1/2 plus 1 equals 1/2. So 1 over 1/2 equals 2u to the power of positive 1/2, or 2 the square root of u or 1 plus tangent of x plus c.